Section 3.6 is, I'm going to do this in multiple parts so we can just kind of look at this type of problem to start with, and then we'll look at other types of problems in future videos. So here we are trying to find the distance from the origin to a point on the graph. And when you do problems like this, it doesn't necessarily have to be the origin that you're working with. This one does happen to be the origin, but it could be any ordered pair. So they are having us look at the point P, which is right here, is x comma y, and it's any point on this graph of y equals x squared minus 1. So the ordered pair xy can't just be any ordered pair like in the universe. Like it's specifically the ordered pair that would be along the curve y equals x squared minus 1. So we might consider, instead of xy, because it can't be anything, the x coordinate can be anything because like the domain of the function is all real numbers. So x can be anything you want, but y can't just be any value that you choose. Y has to follow this rule that we take the input value, the x, we square it, and then we subtract 1. So instead of thinking of this like an ordered pair x comma y, let's instead think of it as the ordered pair x comma x squared minus 1, because that's a more accurate description of where this ordered pair is going to be when we're graphing it. So they're wanting us to figure out the distance between the ordered pair P, which was x squared minus 1, to the origin as a function of x. So I'm just going to kind of draw this differently. I'm going to draw it like bigger. So let me grab, there we go. This is a good one. So this distance here is what we're going to be looking at. I'm going to blow it up a little bit here. Okay. And we're looking at this ordered pair P, which is x squared minus 1. And the other ordered pair, they're having us use the origin in this one. But like I said, it could be any ordered pair. It doesn't have to be 0, 0. And we want to write an equation for the distance between these 2 points. So that's what we're doing in part A. The distance, remember, the distance formula is that big square root formula where we want to subtract the x's and square it. We subtract the y's and square it, add those together, and then take the square root. So it's based on the Pythagorean theorem. So we're going to find the distance between these two ordered pairs. So here we go. Subtracting the x's, I'm going to take the x coordinate from this point, and I'm going to subtract the x coordinate from this point. This one, I've said it a couple times, but remember, it could be any ordered pair. This one just happens to be 0, 0. If it was like 7, 12, we would do x minus 7 here, and then we would use 12 in the other one. And then we are going to add to that, subtracting the y's. So here I have this y value, x squared minus 1. And I'm going to subtract from that the y value of my other ordered pair, which happens to be 0 in this case, and square that. So I'm going to continue working through that distance formula. So that's going to be just x squared plus x squared minus 1 squared in this case. And then I'm going to need to FOIL that x squared minus 1. So I'll do that kind of off to the side here. Let me get just something plain. Here we go. So distribute x squared. So x squared minus 1x squared minus 1x squared plus 1. Combine those like terms. Oh, x squared times x squared is x to the fourth. You guys were probably trying to tell me that. I couldn't hear you though. So that's going to be x to the fourth minus 2x squared plus 1. Then I have more like terms to combine. So my distance ends up being the square root of x to the fourth minus x squared plus 1. And that's really all I can do for that. So the answer to part A would be the distance expressed as a function of x. So that's part A, would be this guy right here. So D equals square root of x to the fourth minus x squared plus 1. And that's going to tell me, if I were to pick any x value, how far it is from the point I started with, which was 0, 0, to a point on that parabola. So then part B and part C are pretty straightforward. And well, D is as well, but it's a little bit more computation. Just finding the distance for different input values. So part B, what is D if x equals 0? So on B, we have x equals 0. So the distance would be, just substitute 0 in for each of your inputs. So that would end up being square root of 1. So the distance would be 1. Part C, what is the distance if x equals 1? So that will be square root of 1. Oh, shoot, you guys, that was to the fourth power. Good thing that didn't change anything. You got to keep track of me. So 1 to the fourth minus 1 squared plus 1. So that is 1 minus 1 plus 1. That's actually also 1. Interesting. So this ordered pair where x equals 0, when x equals 0, that's this point right here, and we can see on there that distance is 0. When x equals 1, that's this point right here, and that distance is also 1. Cool beans. Okay. Next one, if if x equals, what's it say? Square root of 2 over 2. Okay. Square root of 2 over 2. So then the distance would be square root of 2 over 2 to the fourth power minus square root of 2 over 2 squared plus 1. Square root of 2 over 2 to the fourth power. I'm just going to take a little side trip over there and figure that out. So that means I'm taking square root of 2 over 2 times itself 4 times. So remember, in fractions, we just multiply straight across. So the denominator is easy because it's just 2 times 2 times 2 times 2. So that would be 16. And in the numerator, of course, we know if we take the square root of 2 times itself, we would get 2. And we have another square root of 2 times itself, so times another 2. So this numerator ends up being 4. So square root of 2 over 2 to the fourth is just 1/4. So we have 1/4 minus square root of 2 over 2 squared would be 2 over 4. So 1/2. So 1/4 minus 1/2 plus 1. So let's make these all into fourths. So 1/4 minus 2/4 plus 4/4 would be 3/4, right? So square root of 3 over 4, which is like square root of 3 over square root of 4. And that would simplify to square root of 3 over regular 2. All right. Part E. Part E wants us to use a graphing utility to graph the function. This function d equals d of x for x greater than or equal to 0. And we're supposed to round to 2 decimal places, find the value at which x has a local minimum. And then that's going to give us the point at which our function is closest to the origin. So we're going to be putting our distance function into our calculator. So we'll go in y equals, and we need the square root of, whoops, we gotta go in y equals, y'all. Square root of, okay, x to the 4th minus x squared plus 1. If your calculator doesn't have the same operating system mine does, make sure that you get everything that's inside that radical inside a set of parentheses. If it does it like this, then you don't need the parentheses. Okay. And they want x to be greater than or equal to 0. Excuse me, hiccups. So we can start at 0. Well, let's just look at it and see what we've got going on. All right. They want us to find, I'm going to put it on the standard window, zoom 6, just so we can see why they wanted us to make bigger than 0. Oh, I see. They restricted it to greater than 0 because there's another one over there, so they're after this minimum. So remember that a minimum is like they're referring to a minimum as like the bottom of a valley. Like if you were on a roller coaster, it would be where you get all the way to the bottom and then start going back up. So that minimum is going to be right there. And we can find it by doing second calc. I'll write these down here in a minute on how to find them. And then we go to number 3, minimum. And then it says left bound, right bound guess. So my minimum is right here. So I'm going to put my spider kind of on that minimum. And then when it says left bound, I just arrow to the left a bit and hit enter. And then when it says right bound, I'm going to go back to that minimum, arrow to the right a little bit. And then I'm going to go back to that minimum for my guess and hit enter for a third time. And then it tells me the ordered pair, 0.7071058, and then the y coordinate is 0.8660254. So what they're asking us to find is the value of x at which d has a local minimum. So the x value there would be, they want 2 decimal places, x equals 0.71. Okay, let's write down the steps on how we did that, finding the minimum on our graphing calculator. So we did y1 equals, and we had to type in the function. And then we did the trace. We needed to get to that calculate menu. So we had to push the second button, and then the trace button, which gets us to the calculate menu. And then we chose number 3, which was minimum. And then we had to do left, right guess. Left, right, guess. Okay. And it gave us that ordered pair, x equals y equals, and then we chose the x value to answer our question. The y value, by the way, would be how far away it is. The x value is where along, that's not true. Yeah, that is true. The x value is the x coordinate along the graph. The y value is the distance away from the origin. Okay. Let's see, area of a rectangle. So we're supposed to express the area of a rectangle as a function of x. So our rectangle has one corner in quadrant 1 on the graph of y equals 25 minus x squared, and another at the origin, a third one over here on the positive y-axis, a fourth one over here on the positive x-axis. And so we're supposed to do the area of that rectangle. Remember, area of a rectangle is its width times its height, or its length times its width, or however you express that. Area is width times height, length times width, whatever it is. And so we need to figure out what is the width of that rectangle and what is the height of that rectangle. So looking at my diagram here, the length or width of that rectangle is, I would say, this side. That is the width. And then the height of that rectangle, I would say, is this length here, the height. So if I kind of zoom in on this like I zoomed in on my other graph, just so I can get a better picture of it, this point here, x, y, can move along that curve to anywhere. So similar to how we had done in our last problem, instead of saying x, y, we're going to replace that y with what it actually is going to be, which is 25 minus x squared. So at any given moment, our rectangle is going to have an ordered pair at this guy here will be 0, 0. And then this up here is x, comma, 25 minus x squared. So like if x is 1, then the y coordinate would be 4. So I'll just do like, for example, 1 for the x coordinate. Did I say 4? 25 minus 1, so 24. I don't know what I'm saying. So if this ordered pair up here is at 124, then to get there, I would go over 1 unit, up 24 units to get to that ordered pair from the origin. So we should be able to see that this width of that rectangle is going to actually be the x value of that ordered pair. So along here, the width of our rectangle is going to equal x. And then to get up to that ordered pair, we would go up 24, which would be our y coordinate. So the height of our rectangle is going to be the y coordinate, 25 minus x squared. So in our area function, part A says express the area of the rectangle as a function of x. So the area will equal, we've got the width, which was x, times the height, which was 25 minus x squared. So that's going to be our area as a function of x. A of x would equal, I could distribute that if I wanted, so 25x minus x cubed would be my function. What is the domain of A? So for the domain of A, we would want our width to be something between, like our width can't be 0, right? It has to be bigger than 0. So we know that we want the width to be greater than 0. Let's do letter B. We know we want the width, which is x, to be greater than 0. But then we also want the height, which is 25 minus x squared, to be greater than 0. So that 25 minus x squared, that's the one we got to take a look at. X greater than 0, we got that under control. I'm going to factor that because this is what we call a non-linear inequality. So what I need to do is solve the equation that goes with it. So that's going to give me x equals -5, x equals 5. And then do that test chart. So -5, these are open circles, and 5, so I should have made them dashed. Okay. And then I test values in my original inequality. So like if I put -10 in here, 25 minus -10 squared would be 25 minus 100. That is not greater than 0, so that guy would be false. In between -5 and 5, I can test 0. 25 minus 0 squared is greater than 0, so true. And if I test 10, 25 minus 10 squared is, again, false. So from this part, I can see that I would be between -5 and 5. But from this part, I would go 0 to infinity. So I have to fit both of those at the same time. So being from 0 to infinity for one of them, and being between -5 and 5 for the other, I can only have the overlapping part. So from here to here on the orange one, from here to infinity on the blue one, since I can only have the overlap for my answer, I would have to go open circle here, over to open circle here. So my domain is going to be from 0 to 5, so that my area won't be negative. And we will actually see that on our graph when we get to part C. Part C, they want us to graph that on our calculator. So we're going to go into y equals again and put our function 25x minus x cubed. I'm going to go to a standard window and see what we can see. Oh, mercy. So since I'm looking at my domain being from 0 to 5, because this curve represents the area, you can see that I would not want my area to be negative. So I also wouldn't want my width to be negative. So I've got to restrict this to just where my area is positive over here. So let's see. That looks like, well, it should be 5. So let's set our window from 0 to 5 and look at what that looks like. Okay. I need to go up higher, and I don't need to see negative y value. So I'm going to make that 0. Maybe I'll make my y max. I'm just going to make it 100 just to look at it. Okay. So here's what my area curve looks like. So I'm just graphing over in this positive quadrant. That's not the greatest graph, but you get the picture. So any ordered pair on here, every ordered pair has 2 coordinates. The first coordinate is the x coordinate, and it's the width. The second coordinate, which is the y coordinate, is going to be the area because that's what we graphed. So in order for me to find where the maximum area is going to be, I need to find the highest y value. So the max area is going to be at the highest, well, it is the highest y value. And that's going to happen at the maximum right here. So we're going to want to find the ordered pair of that local max. And we just, remember, we learned how to do that a moment. Well, we didn't learn it. We already knew it, but we refreshed our memory. So we do second calc. This time we want to find a maximum 4. Left bound, go to the left. Right bound, go to the right. Guess, go to the max. And it tells us we have 2.886759, and the y coordinate is 48.112522. So the question they asked us is what value of x gives you the largest area, and the value of x would be this one. So this is the x value that gives us the largest area, and this is the largest area. So make sure when you're reading your questions, you're actually answering the question that's asked and not just whatever question you feel like answering, which I probably would have said the largest area instead of the x value that gives the largest area. So make sure that you are reading.